Hello everybody, my name is Peter Close. I do LeetCode questions here on YouTube. Today we're doing number 7, which is reverse integer. A lot of dislikes for this question, but it is nonetheless a very popular question. Given a 32-bit signed integer, reverse digits of an integer. And they give us a couple examples here. 123 is 321, negative 123 is negative 321. Okay, so here are my notes on this problem. And just kind of walk through these steps and explain my reasoning behind this problem. Hopefully it can serve as useful to you. So we need to keep track of 3 pieces of information in each integer. So we need the digit, or the last integer in the number, so 1, 2, 3. We need this 3. We need x, which is the original thing given to us, so that's the 1, 2, 3. We need the reverse, which is going to be the answer, which is going to be the 3, 2, 1. So let's kind of walk through what these informations are, or what they're going to be used for. So digit is going to be the last integer by position. So like I said, 1, 2, 3, 3 is the digit. X, the original value we were given, we must update it. The idea being 1, 2, 3, if we're going to loop through this integer, like for a string, we would go from the position 0 up to the end to the length of the string. But we don't want to do that here. Instead, we want to just keep on making this number smaller. And a good way to do that is just divide by 10 every time. So if we divide by 10, we're going to get 12. If we divide by 10, we get 1. And if 1 divided by 10, because of integer, we're going to get 0. All right, so that's a good way to kind of traverse it, if you may. So how are we going to update these values? Kind of already mentioned this, but digit is going to equal the x modulus 10, or digit is equal to x mod 10 if you like the math notation more. For x, we're going to update it by dividing by 10, like I said. And then for reverse, this is the, I would probably say, the meat of this question, how we're going to express this number. And it's a very clever way to do it is we're going to say reverse, what we calculate for reverse, times 10 plus the digit. Now, that might kind of sound confusing, so I have a kind of like a diagram over to the side here, and we can go walk through this. So they give us x is equal to 1, 2, 3. So we're going to initialize reverse to equal 0, okay? And then what we're going to do is we're going to calculate the digit, which is just 1, 2, 3 modulus 10, which is equal to 3. We're going to update x, which is 1, 2, 3 divided by 10, which is equal to 12. And then we're going to calculate reverse, which is 0 times this value right here, which happens to be this reverse value. So the reverse is 10, so 10 times 10, or 0 times 10 is 0. And then we're going to add on the digit, and we get 3. Okay? Next time, we're going to take this reverse, and we're going to use it in our next calculating reverse. So we calculate the digit, we update x because we're looping through this, right? And then reverse is now equal to the previous reverse, which is 3, times 10, so this is 30, plus 2. We get 32. We do this exactly the same, this again. Reverse is used in our new calculating for reverse, which is 32 times 10, which is 320. Then we add 1, which is our new calculated digit. We get 321. Right? So we're going to take our previous reverse value, we're going to multiply it by 10, and then we're going to add the digit that we're currently at. Right? So we're going to get 3, multiply that by 10, we add on the next digit, we get 32, multiply by 10, add on the next digit, we get 321. And then we're going to return the reverse. So we also need how are we going to iterate through this? I kind of mentioned this before, but here's kind of the formal definition or explanation. Today we will use a while loop. In particular, we will use a loop through our process, as long as x is not equal to 0. So we're going to always keep on doing our steps as long as x is not equal to 0. And we can do this because we know integers are truncated. So 1 divided by 10 is going to equal 0 because it is equal to 0.1, but because integers are not real numbers, it would just be 0. Every iteration, we will divide x by 10, like we said. So because x is an integer, x is equal to 0 when x is less than 10. So let's do this. So we first calculate reverse by looping through the above steps, we will then check if the absolute value of the reverse is greater than the constraint, absolute value integer. So this is, in this question, they give us a constraint. Assume we are dealing with an environment which could only store integers with the 32-bit signed integer range. Return 0 if the reversed integer overflows. And what this is basically saying is that an integer can only be so big. Let's say let's say, for the sake of dumbing it down or simplifying it, that the max integer can be is 23, right? Let's just say that the max is 23. Well, when we reverse that, we get 32. 32 is greater than 23. So the max for integer is some crazy number, right? I think it's 2 to the 32nd power. So when we reverse that, if the last digit of that number is greater than the very first digit of that number, when we reverse it, the number is going to be bigger. So we're going to be out of bounds. So we're going to overflow, right? So this constraint is basically saying we have to make sure that if it is above what an integer can be, we just return 0. So this is probably this is how we're going to do it. We're going to go ahead and say, this is kind of summarizing a lot of other things mentioned in the problem. So we'll first calculate the reverse by looping through the above steps. We will then check if the absolute value is greater than the constraint. Okay, an absolute value, because a negative 1, 2, 3, when we reverse that, is a negative 3, 2, 1. It's still negative, so we have to make sure that when we take the absolute value, we can check it against the absolute value, or the largest value for an integer, which happens to be integer.max value. If it is greater, then we just return 0, like I said, because it's overflowing. And if it's no, we return reverse. Note, we use for rev because we use long for reverse, because the value of rev could be greater than the max value of an integer. So at the end, and I'll go through this code when I type it up, we're gonna cast our answer to an integer. After we do it, before then, we're gonna check this value. So don't worry if it's a little confusing. I'm gonna go walk through the code step by step on LeetCode now. So that's the explanation, and I'll show these notes afterwards, and hopefully they make more sense. This problem was very, very difficult for me when I first started it, but once you get the hang of it, this idea, then that's not too bad. So we're first going to go ahead and we're going to create or initialize our reverse, which is going to be called rev, and we're going to set equal to 0. And then we're going to say digit, right? So we're going to initialize rev, and then we're going to declare digit. And then we're going to go ahead and loop through this integer. So while x is not equal to 0, what we're going to do is we're going to take our 3 steps, right? Our 3 steps being digit is equal to this, x is equal to this, and reverse is equal to this. So we're going to do those 3 steps. We're going to say digit is equal to x modulus 10. X is equal to x divided by 10. And then what we're going to go ahead and do is we're going to calculate reverse, which is reverse is equal to reverse times 10, the previous reverse value that we had, plus our digit. And now we have to check if it's overflowing, right? We got to check that, if we had a 23, like I was just explaining, if I had a 23, if this is the max value that we could ever have, the reverse of this is going to be 32. And because 32 is greater than 23, we are out of bounds, and therefore it's overflowing. So we have to make sure that this reverse is less than the max value integer can be. And how we're going to do that is we're going to go ahead and we're going to just make sure that we're going to check the absolute value of reverse and make sure that it is less than the max value. So math.abs rev, if it is greater than, right? If this value is greater than, we have to return 0. We have to make sure, this is kind of like saying we're making sure that it's less than the max value. max value. And we're going to return 0 if that's the case. Else, we're going to return the reverse. So let's go through this solution one last time. So why is it long? It's long because we don't want to have to deal with a number that's larger than what an integer can be, right? This reverse is already being calculated, and we check if the absolute value of reverse is greater than integer after we calculate this reverse. So we just use long so we don't have to necessarily worry about the overflow issue, and then we check for the overflow issue after the fact. So we calculate digit, calculate x, calculate reverse, and then we check, and digit is equal to x modulus 10, x is equal to, digit is equal to x modulus 10, x is equal to x divided by 10, reverse is equal to reverse times 10 plus digit, and then if math.absolute value of reverse is greater than integer.max value, what we're going to do is we're going to return 0, else we're going to turn the reverse. Hopefully this makes sense. We're going to submit this really quickly. It might be in some type issue. Yes, that's exactly what I thought. We have to cast this to int. The reason because we want to return an integer. We don't want to return a long. There you go. Yeah. So 100%, 1 millisecond, which is really, really good for this question. If you wanted to make the storage a little better, what we could do is we could remove digit and just take this and place it in for reverse, or for digit right here. But that's just something small. Here are the notes for this question. Feel free to pause the video here and take a look at this. Hopefully it is explained in a way that you can follow and you can understand. And yeah, if you have any questions, feel free to just leave a comment. I will continue to go through these LeetCode questions and hopefully get better at them myself. And you guys have a great rest of your day. Thank you.